There is a place in the universe so empty, it shouldn't exist. A region so vast, so dark, that if our galaxy were inside it, we might never know other galaxies existed at all. This is not a black hole, it's not a nebula. It's something far more disturbing, a hole in the universe itself. Tonight we enter the Boötes Void. When we look up at the night sky, we see stars, constellations, the faint band of the Milky Way. But that is a lie of scale, because beyond those stars lies a universe filled with trillions of galaxies, woven together into a vast cosmic web. Zoom out farther, and space isn't just random. Galaxies cluster into filaments and walls, separated by enormous gaps called voids. These voids are common, but they're usually modest, small pockets in the universe's structure. Then, astronomers found something that broke the pattern. In the northern sky, in the direction of the constellation Boötes, they discovered an emptiness so immense it defied every expectation. A spherical region roughly 330 million light-years across, containing almost nothing. To understand how insane that is, imagine plucking out a huge portion of the universe's map and finding nearly pure nothingness where there should be thousands of galaxies. This is the Boötes Void, the loneliest place we've ever found in the cosmos. Some astronomers called it a cosmic catastrophe. Others quietly wondered if our understanding of reality itself was incomplete, because if the universe can grow a hole this big, what else is hiding in the dark? In this documentary, we're going to journey into that vast emptiness and uncover how the Boötes Void was discovered almost by accident, why its size shocked the scientific community, what it feels like, scientifically and emotionally, to imagine living inside such isolation, and the terrifying theories about what this hole in the universe might really mean for the fate of everything. We'll explore the cosmic web, dark matter, and the large-scale structure of reality, and ask a chilling question. Is the Boötes Void just a natural glitch in the universe, or a sign that something far stranger is shaping the cosmos? If the idea of a hole in the universe unsettles you, stay with me. By the end of this video, you'll never look at the night sky the same way again. And if you're drawn to the darkest corners of the cosmos, hit subscribe and turn on notifications so you don't miss the next journey into the universe's most disturbing secrets. Now, let's enter the void. To understand why the Boötes Void is so disturbing, we first have to understand what the universe is supposed to look like. Not from Earth, not from inside the Milky Way, but from far, far above. As if we could step outside reality and see the cosmos as a whole. If you could pull back far enough, past the stars, past the nebulae, past the spiral arms of galaxies, you would see that the universe is not evenly filled with matter. It is not a smooth ocean of galaxies. It's a web. Astronomers call it the cosmic web, a vast, three-dimensional skeleton made of thin threads called filaments, massive clusters where those filaments intersect, and between them, great dark empty regions called voids. Imagine a spiderweb made of galaxies. At the intersections, bright knots of light, galaxy clusters, superclusters. Along the strands, chains of galaxies stretching for hundreds of millions of light years. And in between the strands, the gaps, the voids. For a long time, we had no idea this structure even existed. All we saw were tiny pieces of the picture, the galaxies close enough and bright enough for our telescopes to reveal. But in the late 20th century, something changed. Astronomers began to map the universe in 3D. Every galaxy carries a secret in its light. Because the universe is expanding, galaxies are drifting away from us. And the farther they are, the faster they recede. Their light is stretched, shifted toward the red end of the spectrum. We call this effect redshift. By measuring that redshift, astronomers can estimate how far away a galaxy is, not just where it appears on the sky, but where it sits in three-dimensional space. So scientists began a new kind of project, redshift surveys. They pointed telescopes at patches of sky, measured the redshifts of thousands of galaxies, and plotted their positions like glowing dots in the dark. At first, the pattern looked random, but as the data grew, a strange image emerged. Galaxies weren't scattered like sand. They were arranged like foam. They formed walls and chains, massive structures spanning hundreds of millions of light years. Between those structures, enormous bubbles of space, almost empty, called voids. This was the cosmic web, a universe where matter clings to filaments, leaving behind great caverns of darkness. Voids by themselves are not unusual. In fact, they are a natural consequence of gravity and time. In the early universe, matter wasn't perfectly uniform. Some regions had just a little bit more density than others, slight overdensities and underdensities. Over billions of years, gravity pulled matter toward those slightly denser regions, forming galaxies, clusters, and filaments. The underdense regions, the places that started with less matter, were gradually drained. They expanded into the voids. Most voids are impressive but manageable, tens of millions of light years across, large but consistent with what our models of the universe predict. If you found yourself inside a typical cosmic void, you would still see galaxies in the sky. You'd still have neighbors, distant but there. A void is not absolute nothingness. It's just less. But then, astronomers came across something that was not just less. Not a typical gap, not a normal bubble in the cosmic web. They found a void that shattered their sense of scale. In the 1980s, as redshift surveys became more detailed, teams of astronomers began to chart bigger and bigger regions of the sky. One such effort looked toward the constellation of Boötes, a nondescript patch of the northern sky. They expected to find the same general pattern: filaments of galaxies, clusters here and there, and the usual patchwork of moderate voids. Instead, their maps began to show something unusual. Point by point, galaxy by galaxy, they were building a 3D model of this region of space, and a strange emptiness started to appear. At first, it might have looked like a gap in the data. Maybe the telescope had missed something, maybe the survey was incomplete. But as they continued adding more galaxies, extending their reach, the gap didn't close. It grew. A vast spherical region, suspiciously clean, emerged in their maps. Where there should have been thousands of galaxies, there were almost none. The numbers were unnerving, roughly 330 million light-years across. To put that in perspective, if the Milky Way sat at one edge of this region, light would have to travel for hundreds of millions of years just to reach the opposite side of the emptiness. Astronomers double-checked their instruments. They re-examined their data. They asked, is this a real feature of the universe or an illusion created by our methods? Normal voids are like gaps between threads in a web. The Boötes region looked different. This wasn't a casual gap. It was like someone had taken a cosmic eraser and carved out a sphere of near-total emptiness from the fabric of the universe. Statistically, a void this large and this empty was extremely unlikely if the universe behaved the way our models predicted. Astrophysicists ran simulations. Could random fluctuations in the early universe naturally produce a void of this magnitude? In some scenarios, yes, but only rarely. The Boötes Void sat on the edge of what seemed possible, like a cosmic anomaly, right at the boundary of probability. To some, it was just a strange but natural outlier. To others, it was a warning sign, a hint that we might be missing something fundamental about how structure forms on the largest scales. By now, the Boötes Void had earned a name, and quietly, among those who studied it, a reputation. They knew it was big. They knew it was empty. But what about the few galaxies that did live inside it? What would existence look like for anyone trapped inside that cosmic desert? To truly feel the horror of this hole in the universe, we need to go inside it. We need to imagine life in the loneliest place in the cosmos. So let's cross the boundary, leave behind the crowded filaments of galaxies, drift away from clusters, superclusters, and the bright knots of the cosmic web, and fall into the Boötes Void. At first, you might not notice anything wrong. Space, after all, always looks empty. But as you travel deeper, something starts to feel off. The familiar backdrop of clustered galaxies begins to thin out. Where you would normally see great sweeping arcs of light, chains of galaxies stretched across the sky, you now see only scattered, lonely points. The sky doesn't go completely dark, but it becomes sparse, hollow. You are entering a region hundreds of millions of light years across, where matter itself has almost given up. Now imagine a galaxy living in the heart of this emptiness. Not a grand spiral like the Milky Way, with a bustling neighborhood of companions, but a solitary island of stars, adrift in a black ocean. For any hypothetical observers living there, the universe would look very different from how it looks to us. From Earth, when we look deep into the cosmos, we see galaxies in every direction. Tens of thousands in a single long-exposure image. Inside the Boötes Void, the sky would be almost insultingly quiet. Other galaxies would exist, yes, but each one would be unimaginably far away. The nearest large galaxy might be hundreds of millions of light years distant, its light so faint, so diffuse, that detecting it would be a technological miracle. If a civilization evolved there, it might look out into the cosmos and conclude that it was truly, utterly alone. Think about that. On Earth, it took us until the 20th century just to understand that our Milky Way is one galaxy among many. We had bright neighbors in the sky, the Andromeda Galaxy, the Magellanic Clouds, and still, for most of human history, we thought everything we saw was part of a single island of stars. Now imagine starting that journey of discovery from a place where the sky offers you almost no clues that anything else exists. A galaxy in the Boötes Void would still follow the laws of physics we know. Stars would form and die. Planets would orbit. Black holes would lurk in galactic centers. But on the largest scales, it would be stranded. No rich galaxy clusters nearby to fall into. No dense filaments to feed it with fresh gas and material. Just isolation. Over billions of years, its stars would burn out. Its gas would be used up. And with no nearby galaxies to merge with, no fresh infall of matter from the cosmic web, its future would be quiet. In cosmology, we often talk about the universe's long-term fate, the slow dimming of galaxies, the expansion of space, the approach of heat death. But inside a void like Boötes, that future is not just a distant destiny, it's a preview. Living there would be like existing in a fast-forward version of the universe's final loneliness. Now let's push the thought experiment a little further. Suppose there is an intelligent civilization in one of those few galaxies, floating in the heart of the Boötes Void. They build telescopes, they map their surroundings, they study the faint cosmic microwave background, the afterglow of the Big Bang, just like we do. What would they conclude about reality? They might infer that the universe began hot and dense, then expanded. They might measure the same fundamental constants we do. But when they look for other galaxies, they would find almost nothing. Perhaps a handful, tiny smudges of light separated by inconceivable distances. Would they ever suspect that beyond their dark horizon, the universe is full of galaxies, clusters, structures so massive and rich that, from their vantage point, they are completely invisible? Or would they decide that their lonely patch of space is all there is, or all there ever was? In a strange way, the Boötes Void is not just a physical feature of the universe. It's an existential trap, a place where a mind could evolve, look out into the cosmos, and be fundamentally misled about the true nature of everything. We often wonder if we are alone in the universe. But the Boötes Void forces us to consider a different question. How many civilizations might exist in regions so isolated that for them, the universe is effectively empty? Even if, on the grand scale, it's not. There's another layer to this cosmic prison. Even if a void civilization somehow learned that beyond their horizon lies a richer universe, what could they do about it? Space is not just big, it is expanding. The fabric of the universe is stretching, and on the largest scales, that expansion is accelerating. That means distant galaxies are not just far away. Many of them are receding from us so quickly that no signal we send will ever reach them. The light we see now is a fossil, a message from a past that is already gone. Inside the Boötes Void, the few neighboring galaxies would already be incredibly far apart. As cosmic expansion continues, even those dim companions would drift further and further away, until one day they slip beyond each other's cosmic horizon. From that point on, no light, no information, no ship, nothing could ever cross the gulf between them. Each galaxy becomes truly alone, not just practically unreachable, but physically cut off by the expansion of space itself. The Boötes Void is not just empty in space, it is a preview of emptiness in time. Standing here, in our relatively crowded corner of the cosmos, it's easy to feel small. We are one planet, around one star, in one galaxy, in a universe of trillions. But the Boötes Void reminds us of something darker. We are also lucky. Lucky to exist in a region rich enough to reveal the universe's true structure. Lucky to see the cosmic web. Lucky to know that voids like Boötes exist at all. Because if we had been born in that hole in the universe, we might never have known there was a web to begin with. We would have looked into the dark and seen only ourselves. So what carved this enormous wound into the cosmos? Is the Boötes Void just an extreme, but natural product of gravity and expansion? Or does it hint at something deeper? Dark matter, exotic physics, or even more unsettling possibilities? In the next act, we'll explore the leading theories behind how such a monstrous void could form, and why some astronomers quietly wonder if the Boötes Void might be telling us something about the ultimate fate of the universe itself. We know what the Boötes Void is: a vast, haunting emptiness, a wound in the cosmic web. But how does something like this happen? What force could carve out a region 330 million light-years across and leave it almost completely barren? The first place to look is not in science fiction, but in the standard model of cosmology. In our best understanding, the universe began almost perfectly smooth, a hot, dense plasma with tiny ripples in density, 1 part in 100,000. Those tiny ripples, seeded by quantum fluctuations in the very early universe, were stretched to cosmic scales by a brief, violent growth spurt called inflation. Over billions of years, gravity amplified those tiny differences. Where there was slightly more matter, gravity pulled in even more. Those regions collapsed into galaxies, clusters, and filaments. Where there was slightly less matter, those regions were drained. They expanded, thinned out, becoming the voids we see today. In that sense, voids are not strange. They are the negative space sculpted by gravity's relentless preference for clumps. In computer simulations, cosmologists can recreate this entire process. Start with a nearly uniform universe. Add tiny quantum seeds. Let gravity and dark matter do their work. And after billions of years, a cosmic web appears on the screen. Filaments, clusters, and yes, voids. Some of those simulated voids grow very large. So one explanation for the Boötes Void is brutally simple. It is an extreme case of a completely natural process. A region that just happened to start a little emptier than average, and over cosmic time, that small disadvantage was amplified into a vast, yawning cavity. But scientists are not easily satisfied. When the Boötes Void was first measured, its sheer size and emptiness pushed the limits of what those simulations predicted. Not impossible, but rare, like rolling a million-sided die and getting exactly the darkest, most dramatic outcome. So cosmologists began to ask, is this void just a statistical fluke? Or is it a clue, a sign that something about our model of the universe is incomplete? To understand the next layer of this mystery, we have to talk about something we cannot see: dark matter. All across the universe, galaxies rotate too fast. Clusters hold together too strongly. The visible matter, stars, gas, dust, is not enough to explain their motions. So we infer the presence of an invisible substance, 5 times more abundant than normal matter: dark matter. Dark matter doesn't glow. It doesn't interact with light, but it does feel gravity and creates gravity. Others have flirted with more dramatic speculations. What if, they ask, a region like the Boötes Void is the scar of some ancient cosmic event? A collision between bubbles of space with different properties, an imprint left by a phase transition in the early universe, like a crack in cooling glass. Or even, in the most extreme, though deeply unproven speculations, a place where our universe once brushed against something beyond it. There is another layer of subtlety here. We call the Boötes Void empty, but that's not quite true. Later observations revealed that it is not a perfect vacuum. Buried inside this vast region are a few dozen galaxies, small, scattered, and astonishingly isolated. Some of these galaxies are oddly placed, clustered toward one side of the void, as if they had been pulled or left behind during the void's formation. Others seem strangely unaligned with the structures outside. These details may hold clues to whether the Boötes Void is just a statistical outlier or a relic of something more complex in the early universe. Whether natural or exotic, the Boötes Void is not just a curiosity. It is a glimpse of where the universe is heading. As cosmic expansion accelerates, matter will continue to drift apart. Filaments will thin. Clusters will become more isolated. Galaxies that are now bound together will gradually fall out of contact. Given enough time, the entire universe will come to resemble a vast network of ever-deepening voids, with small islands of matter slowly dimming out, alone. In that distant future, the Boötes Void will no longer be an exception. It will be a preview of everywhere. We've explored the structure of the void, imagined life inside it, and examined what might have carved this monstrous hole in the cosmos. But there is one more question to confront. A question not just about physics, but about meaning. What does it say about our place in the universe that such vast, uncaring emptiness exists at all? In the final act, we'll step back from the data, look again into the dark, and ask what the Boötes Void truly reveals about existence, luck, and the fragile, fleeting light we call life. Stand back for a moment. We've flown across hundreds of millions of light years, traced the filaments of the cosmic web, fallen into a vast, silent cavity in space, and imagined the lives of galaxies trapped in that darkness. Now, let's look again at the Boötes Void. There it is, a region so empty that, if it replaced the volume around our Milky Way, we might not know the rest of the universe even exists. A place where entire galaxies live and die in almost total isolation. A wound in the sky, and a mirror held up to our own fears about meaning and loneliness. On paper, the Boötes Void is just a data point, a low-density region in a universe governed by gravity, dark matter, and expansion. But we can't help it. We're human. We project. We see this monstrous emptiness, and we feel something deeper, the fear of being alone. The realization that most of the universe does not care whether we exist. The knowledge that, on the largest scales, our stories, our civilizations, our entire species fit comfortably inside the smallest rounding error of cosmic statistics. And yet, here we are, on a small planet around an ordinary star, in the outskirts of an average galaxy, looking across the void, measuring it, naming it, turning its emptiness into understanding. We like to say that we are insignificant, but the Boötes Void adds a twist to that idea, because not every galaxy gets what we have. We live in a cosmic city, a crowded neighborhood of galaxies, clusters, and structures dense enough to reveal the true shape of the universe. A civilization born inside the Boötes Void might never know that. They might live and die believing that the universe is almost entirely empty, that their lonely island of stars is all that ever was. So yes, we are small, but we are also lucky. Lucky to exist in a time and place where the sky still whispers its secrets to us. Lucky to stand on the edge of the void and see it for what it is. Not the whole story, but one dark chapter in a much larger book. One day, even our luck will run out. As the universe continues to expand, galaxies will drift away, their light fading into infrared ghosts and then into silence. Future observers, trillions of years from now, if any remain, might look into their skies and see only their own galaxy, wrapped in darkness. For them, the entire cosmic web will be gone. The universe will look a lot like the Boötes Void. In that sense, this hole in the cosmos is not just somewhere out there, it is a preview of everywhere, the future written in absence. So what do we do with this knowledge? We could let it crush us, The vastness, the indifference, the creeping certainty that most of reality will never know we were here. Or we can treat it as a challenge, a reminder that meaning is not handed to us from the stars. We make it, in the stories we tell, in the questions we ask, in the fragile, temporary networks of minds and memories we build on this tiny world, while we still can. The Boötes Void doesn't care that we exist, but we do. And for as long as we can look into the dark and feel something, awe, fear, curiosity, wonder, then in this thin slice of time, in this one bright corner of the universe, the void has not won. If this journey into the hole in the universe left you with that strange mix of awe and dread, you're exactly who this channel is for. Tell me in the comments, if you were born inside the Boötes Void and saw almost nothing in your night sky, do you think you'd still search for meaning out there? Or would you decide the universe ends with you? If this episode made you feel small, hit like. If it made you feel strangely lucky, subscribe and join us as we keep pulling back the curtain on the universe's darkest secrets. And if you want to go even deeper into cosmic horror, your next stop is right here. When Earth Meets the Event Horizon, a cosmic horror story. In that video, we don't just look at a void in space. We drag our entire planet to the edge of a black hole's event horizon and watch what happens when reality itself starts to come apart. Click it now, before the light fades, and I'll meet you on the other side of the horizon.